Our last chair is Professor Tim Fisher, and he's chair of two departments in one, mechanical and aerospace engineering. Now, E.T. earlier was trying to tell you that since civil is in civilization, that must be the earliest technology, would be the civil engineers. But I think Professor Fisher differs because his research is in heat transfer, and as he was telling me this morning, certainly the earliest human technology was heat transfer, think fire. So, and I think as I've been giving him a lot of heat recently, and he can really take the heat. I think he's gonna give you a great introduction to mechanical and aerospace engineering. I wanna tell you that as a student at Cornell University, Professor Fisher played baseball, and he did it well enough that as a graduate student at Cornell University, he was an assistant coach for the baseball team, as well as developing, you know how Apple has some really cool products? One of the reasons why they're cool is because of heat transfer technology that Professor Fisher developed that was actually in an early Apple computer that had no fan. So, for a computer to not have a fan, you have to solve the problem of heat transfer, which Professor Fisher did. So here to tell you about mechanical and aerospace engineering is Professor Fisher.
Thanks, Rick, and thank you all for attending, and congratulations to everyone. It's such a difficult process to get admitted here to engineering, as was mentioned before. It's too difficult, right? There's rooms full of similar size of people who have credentials that are very similar, almost indistinguishable from you, who did not get in. In my discipline, mechanical and aerospace engineering, it's been particularly difficult to be admitted lately, so congratulations to you. I'm going to talk a little bit about our field. I'll bring it back. I think Professor Dunn should have probably been the last one because he ended on a more jovial note. I'll try to fit some jokes in, but mechanical engineering is really the study of things in motion, the dynamics of things that are moving in general. And so some of that's obvious. Robotics is a good example, or an airplane. But it's also things that you don't see, like fluid flow and heat flow, which is a form of energy, even charge flow. Electrical engineers get a piece of that, but we do a lot with it as well. And so it's really how things move, but not just understanding how or why they move, but then controlling them on top of that. So that's really what mechanical engineering is about. We have fantastic things going on in robotics, but also in rockets, in energy systems, in controls, and so forth. So I'll have much more to say about that at the specific session after this meeting. And I just wanted to say a few more things about how we do things at UCLA. I've only been here for 2 years. I came from a large Midwestern university before that. I would say that to distinguish what happens at UCLA versus what I'm used to, having spent 15 years back there, they're both great places, first of all. But we definitely have an attitude of students teaching students much more here. And that's all good because, especially for mechanical and aerospace engineers, one of the things metaphorically that we'd like to talk about is how we teach students to be dynamic. That means to change, to be able to acquire knowledge quickly. And that often happens best in peer learning. And so we have all kinds of projects, more and more. I hope that you get a chance to see the makerspace. It's really an impressive infrastructure for students, and it's largely run by students, right? The faculty have oversight. That's the other thing that's interesting about the way that we do things in terms of our engagement with faculty. We have more faculty relative to the student body here than most places, so that we're a small engineering school by some measures, but we have a large faculty and a relatively low student to faculty ratio. So it's intimate, it's close. I have 21 meetings starting tomorrow and going through Wednesday in week 3 to meet with my undergraduate advisees. I'm admitting that. I know you heard earlier it was supposed to be in week 2, but I was in Washington, D.C. last week, so I had to move it to week 3. Sorry, Dean Wessel, okay. 21 meetings in the next 3 days with my undergraduate advisees. At the last place I was for 15 years, I never had a meeting with a formal advising meeting with an undergraduate student. So that kind of tells you maybe best how the difference in the approach. At the same time, so we have more faculty. We have fewer kind of professional staff to structure things. The students end up structuring it. We teach leaders and their dynamic in the process. So we have all kinds of clubs. I'll say so much more about this, but the student projects and student clubs drive this place, and they drive the innovation that's happening here. It's student run, it's faculty advised, right? And so, but we let your children, if you're a parent out there, become a leader in technology. That's really what happens if you choose to come here in UCLA engineering, and especially in mechanical and aerospace engineering. So with that, I'll finish my comments and we'll move on. Thanks.